Hello, I'm Ted DeBoda, Executive Director of NASCO, the National Association of Sewer Service Companies. In response to requests from member organizations and municipalities throughout the U.S. and Canada, NASCO developed the Jetter Code of Practice. It provides a general guide to sewer cleaner operators for the safe and efficient use of sewer cleaning and jetting equipment. The manual proved to be very popular and is now available in Spanish. This video is the next step in NASCO's initiative to help municipalities and organizations train their junior operators and provide an ongoing reference for the more seasoned operator. Our hope is that by watching this video, you will learn the basic nomenclature and capabilities of jet and jet vac equipment, identify and understand capabilities of the components that make up a jet vac truck, be able to describe how each of these components work, learn about easement machines, tools for sewer cleaning and other equipment, understand step-by-step procedures for basic sewer cleaning operations, determine nozzle selections for proper cleaning, and become aware of specialized techniques for cleaning large diameter sewer pipes. When working with sewer cleaning equipment, safety is a primary concern. Serious injuries can and do occur. While this video portrays safe cleaning practices, our intent is to focus on the sewer cleaning techniques. In no way does this take the place of an updated and comprehensive safety program that includes ongoing training and appropriate documentation. This video provides a basic overview of sewer jetting for beginners and can serve as a reminder of proper and effective practices for the more experienced workers. You can either choose to view this video in one sitting or watch each section individually. Either way, it's our intention that this video furthers our commitment to set industry standards in the assessment and rehabilitation of underground pipelines and to assure the continued acceptance and growth of underground technologies.
Many things have changed throughout the years, but the need for well-maintained and properly cleaned sewer pipes is an ancient problem that we still face today. As early as 3500 BC, the residents of Mohenjo-Daro, located in modern-day Pakistan, saw the need to direct both stormwater and other wastes away from their homes. As a result, the first sewers were built in the form of open-topped drains made of cut stone. About that same time, Babylonians introduced terracotta and kiln-cured pipe. Used mostly for conveyance of water, their method of using pipes has since become the universal standard for transportation of both water and wastewater around the globe. The idea of building sewers soon spread throughout Asia and Europe. The Romans, for example, built sewers of cut stone and clay. And believe it or not, some of these early sewers, built from 1700 BC through 400 AD, are still in service today. In the United States, construction of sanitary sewers began in earnest following the Civil War. The importance of having access through manholes to routinely clean these mains soon became very clear. Sewer workers would use whatever means available to them to clean these early sewers. When available, water was used in a variety of ways, and wooden sewer rods, fire hoses, and the associated tools, nozzles, and other implements soon became necessities of the trade. As time went on, the science of maintaining and cleaning sewers continued to expand. If a sewer had solids deposition that were too intense to be flushed out, tools were developed to scrape the material out of the main to the next downstream manhole, where it was removed by shovels and buckets. If the sewer was too full of solids to get tools through, wooden sewer rods and tools were used to break up and remove the blockage. Sewer workers learned that when a fire nozzle was attached to the end of the fire hose and aimed down into the sewer pipe, the pipes were cleaned easier than ever before. This was the birth of high-pressure cleaning, or jetting, as it has become known. Since these early days, cleaning sewers with jetters and other equipment have become considerably more sophisticated. As a result, they are much more effective, but also much more complicated. Today, our gravity sewers are designed with slopes that provide a self-cleansing velocity, reducing cleaning requirements, but we still have an ongoing need to keep our sewers clean of sediment, roots, grease, and other debris. The modern jet truck, or jetter, has become the tool of choice for keeping our sewer pipes flowing. These high-pressure water systems, when used by competent operators, are capable of cleaning any pipe, from the smallest sewer line to large storm interceptors. The standard piece of equipment used to clean and maintain sewer systems is the jetter. They can be trailer-mounted or truck-mounted and are designed to jet clean pipes via high-pressure water. The primary components of each jetter is a water tank, hose reel, water pump, and an engine. Some truck-mounted units utilize the chassis engine to power the water pump via a power takeoff unit, also known as a PTO. When you combine a jetter with an engine-driven vacuum system, you have what we call a jet vac truck or combination machine. These units have all the features of the jet truck, plus a high-volume vacuum system, suction hose, and a large sealed debris tank. There are a few key things to note about jet trucks and combination machines. Although each manufacturer builds their units in a slightly different way, they all share the same inherent operational hazards. When operating this equipment, you will be working with high-pressure water with pressures from 2,000 to 4,000 pounds per square inch. Improper use of equipment at these pressures can cause serious bodily injury. You should also be aware of the many moving parts on these machines. Read all warning labels and be mindful of the pinch points located throughout the unit. Pumps, drive motors, hydraulic components, swinging booms, and rotating reels all have unique hazards. Pay close attention during the operation of these features. Jet trucks and combination units are inherently safe when properly operated and maintained. Be mindful of the sound and vibration characteristics of your particular piece of equipment. Many times, your sense of hearing or feel will be the first warning of a potential problem. If you notice changes in your unit, be sure to bring it to the attention of your maintenance personnel. The focus of this video will be on the combination jet vac truck. Many of the systems, procedures, and methods to follow apply to all jetters, including trailer and truck-mounted units.
Today's modern combination sewer cleaners consist of two very basic functions: a high-pressure water system and a high-performance vacuum system. The water pumps can range from sizes from 30 gallons a minute to 200 gallons a minute at pressures from 2,000 psi to 3,000 psi. The high-performance vacuum systems can consist of chassis engine-driven positive displacement vacuum systems or auxiliary engine-driven centrifugal compressor vacuum systems. The high-pressure water system consists of three very basic components: the freshwater storage tanks, the high-pressure water pump, and the high-pressure hose reel. The freshwater tanks range in capacity from 500 gallons to 2,000 gallons. The water tank materials can be stainless steel, high-grade aluminum, or various types of poly. The high-pressure hose reel can be located at the front bumper of the truck, behind the cab of the truck, or at the rear of the debris body. Reel capacities range from 500 feet to 1,000 feet. Sewer hose diameters range from 3/4 inch to 1.5 inches. The vacuum system consists of three components: a high-volume vacuum system, a debris storage tank, and a vacuum boom.
Today I'm here with two combination jet vacuum machines. There are two boom features available: the rear-mounted and the front-mounted boom. The boom is typically an 8-inch suction hose that transfers the debris from the job site to the debris tank. These booms have two features: rotation and extension. The rotation ranges from 120 to 360 degrees. The second feature is extension. They range from a fixed boom with no extension to the extendable boom with extensions ranging from 4 to 10 feet. Other options available for the drive system for the vacuum and water pumps: mechanical split shaft PTOs and front-mounted hydrostatic pumps. In the combination market, there are two ways to power the operating systems. Number one is a single engine, uses the chassis engine to operate both operating systems. The second is a dual engine, gives the operator complete independent control of both functions.
The water pump and the vacuum system are the two primary components that all other accessories and operational enhancements are built around. The water pump is the heart of the unit. It has two sides, a water inlet side and a high pressure output side. Water is stored on the truck in the water tanks. It passes through the pump where it becomes pressurized and flows to the hose reel. The hose reel is where most controls for the unit are located. They are hydraulically powered and most rotate and telescope out from the truck to allow for easier operation. The hose reel is designed to feed out and retrieve back a specifically designed jet hose during the cleaning operation. Accessories on the hose reel are used to guide the winding and unwinding process and to keep the jet hose from unraveling. At the end of the jet hose, you will typically find a short section of black hose called the leader hose. This is a sacrificial section of very tough hose that is meant to take the abuse and high velocity impact of material being moved by the water jetting out of the nozzle. Another use for the leader hose is for the operator to see when the nozzle is approaching the end of the line on its way back. The differing material and color of the leader hose is usually a good indicator for the operator to know when to back off power. Nozzles are the tools used by an equipment operator. They are affixed to the end of the jet hose. They restrict flow and create back pressure by forcing water to flow through small jets in the rear of the nozzle. These jets create thrust and propel the nozzle up the sewer line. In today's environment, there are hundreds of nozzle designs. The operator should always remember that no one tool solves every problem. Nozzles should be selected to fit the pipe to be cleaned and the task at hand. We will discuss nozzles in greater detail later in this program. The important item to remember and understand is that many novice sewer cleaning operators struggle with cleaning or waste significant amounts of time because they are simply using the wrong tool. Nozzles are designed by application and sized for specific water pressures and flow conditions. When the material is brought back to the operator, the combination sewer cleaner has the ability to remove the debris using air conveyance. If the water pump is the heart of the machine, the vacuum system is the lungs of the operation. In North America, there are two predominant means to vacuum load debris: centrifugal compressors or positive displacement blowers. With each system, the material is conveyed to the vacuum system through vacuum tubes. The vacuum tube hose system is typically supported by a powered boom or hose cradle. The boom has the ability to raise, lower, and move side to side. Most booms also provide for some degree of in and out movement, or telescoping. The boom will allow the operator to control the vacuum tube placement at the bottom of the manhole. The end of the vacuum tubes is the working end of the system. These units generate a significant amount of suction and are designed for picking up debris in a sewer system. Once the material has been caught up in the airstream, a quick trip through the boom hose ends at the debris body. The debris body is a large storage hopper on the combination sewer cleaner where the debris is stored during loading. Depending on the vacuum system being used, additional filtration may be required. Vacuum relief valves are used to protect the blower from generating too much vacuum and causing an overheating condition. The air moves through the blower and out through an exhaust silencer. This component is essentially a muffler to reduce the amount of noise generated by the blower vacuum system. Once the job is complete, the operation requires unloading the material that has been conveyed into the combination sewer cleaner. Most of the load is usually water, which is put back into the sewer. This process is called decanting. Once the water is offloaded, only solids and sludge remain. This load is then transported to an appropriate dumping site. The debris body door of combination sewer cleaners is hydraulically powered and locked. These types of loads definitely do not want to be accidentally spilled on the roadway. A powered rear door allows the operation to control the dumping or offloading process by controlling the rate of material flow. Most debris hoppers have the ability to raise and dump. Water washout nozzles inside the hopper aid in the offloading process to ensure all material has been pushed out of the hopper and offloaded. All other components on the combination sewer cleaner support the operation. Handguns and hose reels allow for the cleaning of equipment during and after use. Toolboxes allow for storage of various items needed during the course of the day for the sewer cleaning operator. Hazard warning lights and safety cone storage are required for the safe setup and operation of these pieces of equipment in traffic. Pipe storage racks are included for vacuum tube storage and transportation. Working safely is the top priority for every operator, and the two most critical safety elements of any sewer cleaning operation are work zone protection and confined space entry. Work zone protection is the most important first step when setting up on a roadway. A work zone can be a very dangerous place. Nationally, there is one work zone injury every 9 minutes and one work zone fatality every 8.7 hours. Maintaining a safe work area is essential, and thus operators should always work in accordance with local and employer traffic safety procedures. The second critical element of a sewer cleaning operation is confined space entry. When working on a sewer cleaning crew, you are likely to have a need to enter a confined space. Every operator must be familiar with hazards associated with confined spaces. All manholes are confined spaces and must never be entered without appropriate training and safety equipment. In general, the following section will take you through a typical day in the life of a combination jet vac operator. Depending on the project, the day may start at the shop or at the job site. However, regardless of where you start, your day should always begin with a thorough review of your truck and equipment. Daily maintenance is your responsibility. This should include the inspection of all equipment fluid levels. On many units, you may need to move the hose reel in order to gain access to the truck engine. Check the oil level and fluid levels on all major components. Don't forget about the rear engine if your truck is so equipped. You may have to climb up the truck to access some models. Be sure to use existing steps and ladders. When finished, secure any covers or latches. Your truck's hydraulic system powers a number of applications, including hose reel operation, debris tank raising and lowering, and water pump operation. The important points to remember about hydraulics are to keep the fluids topped off. Be careful not to overfill. Since hydraulic oil expands when it gets hot, there should be a minimum and a maximum level on the dipstick or sight glass. During your inspection, be sure to check hydraulic hoses and connections for wear and possible leaks. Leaks are not uncommon on older units and are quite visible because they leave a puddle behind. So take a good look under your truck before departing. The debris tank on your sewer cleaner also requires inspection and maintenance. When the tank is open for dumping, inspect the components inside the debris tank. Look for material buildup at the drain valve, rear door seal, shut-off float balls, decant pumps that are internally mounted, and material hung up on the float level indicator. The water tanks on your unit could be made of several different products such as aluminum, plastic, stainless steel, or even coated mild steel. In any case, they will accumulate sediment. You will find a fine mesh strainer located between the water tank and the water pump. This strainer must be removed and cleaned daily in order to ensure proper operation of the water pump. When you find excessive debris in the strainer, take the time and look in the water tank and flush out any loose material. Before leaving for the job site, you must perform a pre-trip safety inspection of your truck in accordance with local, state, and federal guidelines. This is a condition of your commercial driver's license and must be completed every day before the safe operation of your vehicle can legally take place. Your walk-around will include more than 20 steps, including the confirmation of properly working warning lights and the inspection of every tire for proper inflation. You should also check your equipment to make sure latches are secure and tools are properly secured. Always perform this CDL pre-trip inspection in the same order every time so you don't miss any steps. Make sure your machine is equipped with the necessary personal protective equipment, or PPE. These items include pair of gloves, hearing protection, safety glasses, a reflective vest, hard hat, safety shoes. You also must check to make sure the vehicle is equipped with the necessary tools to perform the day's tasks. These basic tools include the leader hose, a tiger tail, hydrant wrench, manhole hook, and flashlight. Finally, be sure to verify you have all necessary safety equipment. Safety cones, first aid kit, fire extinguisher, safety flares and triangles. Additionally, you may need to enter a confined space during your day, so your truck should also contain a gas monitor and a man-rated tripod with safety harness. Once you've completed all the pre-job safety and equipment checks, you are ready to head off to the job site. Your first stop will normally be at a location to fill your water tanks. Water is a necessary component in the cleaning of sewers, and hydrants are the most common source for obtaining this water. You should always verify you have permission from the owner or local utility to connect your equipment to their hydrants. In many cases, a water permit may be required. When arriving at the fill location, be sure to position your truck with the fill hose on the curb side facing the hydrant. Next, secure your work zone by placing proper signs and safety cones. Remove the hydrant cap and attach a gate valve to the hydrant. Depending on local regulations, you may also need to attach a meter or backflow preventer. Always use a hydrant wrench when attaching a hose or turning the hydrant on and off. The 5-point nut on top of the hydrant is unique, so never use a pipe wrench as it will scar this nut and possibly make it harder for future use by others. Next, you need to flush out the fire hydrant as sediment sometimes is trapped in the hydrant pipe. This sediment can cause damage to your water pump and needs to be flushed out prior to filling. Be sure your gate valve is open and slowly open the top hydrant nut about a half turn and pause. Give it a few seconds and turn again. There is normally a directional arrow located on the top of the hydrant showing the proper direction. Continue in this manner until water is released from the hydrant. You will hear the water as it approaches the opening, and be sure to let it run out until it becomes clear. Then, close your gate valve and finish opening the hydrant, which will take many revolutions to fully open. Following these procedures is very important. You must realize that you are causing significant flow below ground, and damage to the water pipes can occur if too much water pressure is released or stopped too quickly. A slow open and close is a rule of thumb. The hydrant is now ready to use. Attach the water tank fill hose to the gate valve and slowly open the gate valve. The hose will fill rapidly, so pay attention to the sight gauges on your tank and slowly turn the gate valve off when the tanks are full. At this point, you can slowly close the hydrant, remove the fill hose and gate valve, and replace the fire hydrant cap. It is recommended that you walk the water out of the hose before rolling it back up and returning it to its storage compartment. One note of caution at this point. You likely just added more than 10,000 pounds to your truck, so your vehicle will act differently. When braking, you will definitely need to provide additional stopping distance. Be aware and learn how your machine acts when full of water. You're now ready to go to your first job location. Upon arriving at the job site, carefully move your truck into the proper position over the manhole. Set your parking brake. Turn on all warning flashers, strobe lights, and aero boards. And set up your work zone safety equipment. You are about ready to do some cleaning. The next task is to choose the correct tool for the job. Nozzles are your primary sewer cleaning tools. They attach to the end of the sewer cleaning hose and are specially designed for the type of cleaning you are going to perform. Along with the nozzle, you should always use a hose guide, often called a tiger tail. The tiger tail is used to protect the hose at vulnerable points, such as pipe openings. For example, if a hose guide is placed at a pipe opening, the hose will run along the smooth interior of the tiger tail and not scrape or catch on the end of the pipe. They protect against chafing, peeling, and abrasion. They're easy to install and relatively inexpensive compared to replacing or repairing the jet hose. Attaching hose guides should be an automatic part of your setup routine. They need to be placed on the hose and secured in place before nozzles are attached. Depending on the position of the manhole, you may also want to utilize a top roller. Like hose guides, they're intended to protect the jet hose by preventing scraping on manhole rims. Generally speaking, operators should do all they can to prevent unnecessary hose wear and tear in order to extend hose life and prevent possible bursts. At this point, you should activate power to the water pump. This is accomplished by engaging the PTO inside the cab of the truck or starting the rear engine. Hold the rope from the hose guide tube in one hand and lower the nozzle into the sewer line. Be sure to leave 6 to 8 inches of slack in the hose after it touches bottom. Turn on the water pump and jet up the pipe a few feet. Secure the tiger tail and tie it off to ensure it stays in the proper position. Place the hose into the level wind guide and set the hose reel footage counter to 0. If you anticipate the need to remove debris from the sewer, now is the time to get your vacuum system ready. The pipe can be assembled vertically for shallow manholes, or it is common to assemble the pipe horizontally on the ground and then lift the assembled pipe into the air to insert it into the manhole. When positioning the vacuum boom and assembling vacuum pipe, it is important to be careful of all overhead clearances. Pay especially close attention to overhead wires. Before setting up the vacuum system, it's a good idea to make room by moving the hydraulic boom out of the way. Unlock the boom from the transport cradle. The hydraulic boom is operated by a joystick. It has 4 positions: up, down, left, and right. Place the vacuum tube into the manhole. Extensions can be easily attached, if needed, to reach the bottom of the manhole. Move the boom into position. Secure the suction hose to the vacuum tube using clamps. You are finally ready to start cleaning some pipes. Engage power to the vacuum system so you are prepared to vacuum debris that is washed downstream to your location. When it's all set up, engage the water pump at low flow and pressure to begin to feed the nozzle up the line. Only when the nozzle has safely entered the line should you raise the pressure and flow to get the thrust required to feed the hose. Begin to jet out up the line by paying out the hose reel. Watch for debris and obstacles as the nozzle jets up the line. Continue to pay out hose as quickly as possible to the desired length. You will use a higher pressure to jet out the hose than you will when retrieving. Something around 1,500 to 2,000 psi is normal. When the desired length of hose has been paid out, begin to recover the hose slowly to clean the line back to your location. You should reduce your pressure to around 800 psi at this point to limit the likelihood of burping toilets connected to the sewer pipe. The rate at which you retrieve the hose depends on the amount of debris in the line. More debris in a line means a slower rate of hose retrieval. As you pay and retrieve the jetting hose in and out of the line, always watch where the hose is coming from and do not get distracted, as the nozzle could come out of the line you're cleaning. The speed of the hose reel can be fine-tuned by adjusting the speed control knob near the hose reel control lever. Be careful not to overspeed the reel, causing the hose to backlash. When the line has been thoroughly cleaned and the nozzle is ready to be removed from the manhole, reduce the RPMs on the water pump engine until the water pressure gauge drops below 200 psi. The vacuum system should also be throttled down at this time. Using the boom control lever, reposition the vacuum tube so it is clear of the hose and hose guide tube. Remove the hose from the level wind guide and unwind the tie-down line. Hold the rope from the hose guide tube in one hand and remove the hose from the manhole by using the hose reel control lever. The objective in any cleaning operation is to remove solids from the line you're cleaning and reduce the chance of a blockage. Many say, let's just shoot the debris down to the next pipe. But when you do that, you're actually creating 2 to 3 times the work. When you don't vacuum, you not only slow the flow down in the pipe you're working on, you're also clogging the other pipes downstream. Yes, it may be a lot of work to pull the big aluminum stacks out and hook them up, but remember, you will eventually clean faster and make your job easier. Vacuuming should always begin when you start the cleaning process on any job, as this will increase the flow of water in the pipe and allow for the debris to come out of the pipe faster. During the vacuuming operation, it is common to pick up excessive water. Water is wasted space, and decanting is necessary to remove the water and keep only the solids in the debris tank. When the debris tank reaches its capacity, the float level indicator rises and automatically shuts down the vacuuming system. To decant excess liquid from the debris body, you must set out the proper safety equipment. First, unroll the lay-flat hose, which is connected to the drain valve on the rear door, and insert it into the manhole. Then open the valve. As liquid begins to drain, make certain that there are no obstructions overhead, such as power lines, and then slowly lift the debris body to drain off as much water as possible. This process can be repeated many times before the debris hopper must be offloaded. Always exercise caution when transporting a unit with the debris tank loaded. Care must be taken when removing the vacuum pipe from the basins or manholes. Always watch for overhead hazards or obstructions and store pipe in the designated locations. Once the work area has been cleaned, the hose reel and the boom must be properly stored for transport. When dumping the unit, make sure you follow all local, state, and federal guidelines pertaining to dumping the debris body. First, take the handgun out of the toolbox and attach it to the passenger side of the truck. Next, remove the manual safety latch on the rear door. Anytime you are lifting the debris tank, be aware of overhead obstructions or hazards. Slowly open the locks to let any remaining water drain. Never fully open the door without allowing the tension to be removed from the rear door by feathering the locks. Make sure the door is locked and the manual safety latch is removed. After the locks have been disengaged, the cam lock roller and grabber will move away from the door. The body can now be raised. After the material has been drained from the debris tank, turn on the debris body flush out and allow the body to be flushed at system pressure. To flush out the debris body, turn the debris flush out valve on. Spray off the debris body screens and rear door seal for maintenance purposes. As always, continue to be aware of overhead obstacles. While you have the handgun out, this is a good opportunity to wash down your truck. Pay close attention to the undercarriage and remove any mud or debris from your tires. In temperatures at or below freezing, it is important to winter drain the unit to prevent machine damage per manufacturer and employer recommendations. Many machines are outfitted with a winter recirculation system. This system recirculates the water in the pump and hoses to reduce the chance for freezing. It is very effective when you are making short moves from site to site. Hooking up to the recirculation system is a quick, easy process. Take the end of your jet hose and connect it to the winter recirculation fitting located near the hose reel. Be sure to tighten, as the water will be recirculated under some pressure. Once the hose is secure, simply turn on the pump at idle and you're set. Different vehicles will have slightly different procedures, so be sure to consult your maintenance department on proper use. If sewers are extremely dirty, step cleaning is often required. Another technique used by operators is the step cleaning method. The savvy equipment operator would use this technique to avoid the nozzle getting stuck in pipes with heavy debris. In step cleaning, the operator recognizes that the pipe to be jetted has significant debris loads and that rapidly sending the nozzle to the end of the line is not always such a good idea. Anyone who has had to cut a sewer hose and sacrifice a buried nozzle understands this. Step cleaning is analogous to digging a hole for a fence post. Digging a hole requires debris to be removed from the top down, not the bottom up, and that the dirt and debris be removed in stages, not all at once. This is how step cleaning is accomplished. Depending on the debris loads present, the operator should take small bites and clean the pipe in stages, removing debris from a short section before advancing further up the pipe. This can be time-consuming, but is often unavoidable. Pipe cleaning is only one facet of work that you may be doing with your combination machine. Most sanitary sewer collection systems consist of a series of lift stations or pumping stations. Gravity sewers, by nature of their design, gradually gain in depth. Eventually, they become too deep and the sewerage needs to be lifted to a shallower depth. This lifting process is completed with large pumps contained in a tank or what is termed as a wet well. Wet wells of lift stations need to be cleaned, and this is where the combination machine comes into play. Similar to manholes, wet wells are confined spaces, and you need to be very aware of the hazards of working in these structures. Never enter a wet well without proper training and strict adherence to all confined space regulations. The procedure for cleaning lift station wet wells is simple. When arriving at the lift station, you will typically find some type of hatch or large access door. These are larger than your typical manhole because they are used to raise and lower the submersible pumps located at the bottom of the wet well. When you look inside, you will likely see something floating on the surface of the water. This is grease, and it is the primary maintenance issue in many wet wells. Cleaning begins by assembling your tubes just like you did when working in a manhole. Once assembled, this tube stack may be very long, so pay close attention to any overhead obstructions as you lift them into place. You will likely be working a distance from the front of your hose reel, so connect your control pendant to the front of the truck. Connect the vacuum tubes to the flexible boom hose and find your handgun and connect it to your handgun reel. If you haven't already, it's time to turn on your water pump and vacuum system. These are the same controls you use during pipe cleaning operations. You will need to turn a valve to activate water to your handgun. Most handguns have a preset pressure regulator. This regulates the pressure to manageable levels so you can safely control the spray pattern. Wet well cleaning is typically a two-person operation. One person operates the handgun, while the other operates the boom controls and vacuums up the grease and debris. Move your boom around the surface of the water to remove the grease, while your partner breaks up the grease mat with the high-pressure water. Be sure to wash down the walls, rails, and other items within the station. Debris will also gather below at the bottom of the station. The vacuum unit on your machine is capable of working underwater. Special vacuum tubes are used for this operation. Your supervisor will provide additional training on this technique. In many situations, subsurface drainage, both sanitary and storm, are not easily accessible from roadways or right-of-ways. Combination jet vac trucks used to clean these pipes are not designed to be taken off the roadway. There are innovative tools and equipment available to be used in these situations. Easement machines are wheeled or tracked machines with a hydraulic or chain-driven hose reel attached that is an extension of the hose reel on the jet vac truck. Easement machines are manufactured to access manholes in hard-to-reach locations such as backyards or wooded easements not accessible by large equipment. These units act as an extension of the hose reel on the combination truck. The water volume and pressure from the water pump on the jet vac truck is circulated through the high-pressure hose on the easement machine and used to clean the pipe in the same manner as the hose reel on the jet vac truck. Most easement machines are in a skid steer configuration. Two-hand controls will operate the machine. When you push the two forward, you'll go forward. When you push one forward, you will turn in that direction. A small horsepower gasoline engine is mounted on the easement machine and provides power to a hydraulic motor. As with any of the equipment you operate, daily maintenance is a must, so be sure to check your fluid levels. The high-pressure hose from the jet vac truck is attached to the easement machine. Make sure this attachment is tight, as high-pressure water will be flowing through this machine. Most locations will allow you to use the power of the machine to pull the truck-mounted jet hose with you to the work site. This is always at least a two-person operation. One person pays out hose from the truck, and the other drives the easement machine. This is a very versatile operation, as it allows you to work efficiently more than 500 feet from the truck. Position the machine squarely facing the pipe or manhole. This will make retrieving the easement machine jet hose easier. Pay out some hose by operating the hose reel control valve and attach your tiger tail and nozzle. As you position the hose into the pipe, you may need to get creative on how you secure your tiger tail rope. Good communication is critical when working with these units. When ready, contact your partner and have him turn on the water pump and increase the water pressure. It will take a few moments for the water pressure to reach the nozzle, as you now have 500 feet of extra hose attached to the system. Reset your hose counter to 0. Pay out the hose and start pipe cleaning. The knob on the hose reel control valve will adjust the speed of the hose reel. Make multiple passes within the pipe to ensure proper cleaning. In situations accessible by an easement machine, but not hard pipe for vacuuming, alternative methods of debris removal must be considered. If the debris in the pipe being cleaned is minimal, manned entry following all confined space procedures is an option. The operator, after pulling debris back into the manhole and shutting down all water pressure from the jet vac truck, can perform a proper manned entry into the manhole with shovels, buckets, and other hand tools, and physically remove the foreign debris from the manhole. When cleaning sanitary or storm lines during wet weather or pipe located in environmentally sensitive areas, precautions need to be taken to minimize the impact of the equipment's footprint. Fiberglass, plastic, or wooden equipment mats are available to be set up in the access path to the manhole. Some cleaning projects will require specialized tools or equipment in order to complete the job. Bucket machines can be an effective cleaning method for the removal of sand and roots in pipes where combination machines cannot access or where pipe flows are excessive. This is considered by the industry to be a mechanical cleaning method. Bucket machines are basically just as described: a bucket dragged through the line by two trailer winches. One of the winches is a power winch, and the other is a retrieval winch. In cleaning a sewer with a bucket machine, the winches are set up on the two manholes of a line segment. The power or pulling winch is positioned to pull a clamshell-shaped bucket into the debris, and once the bucket is full, the retrieval winch drags the bucket back to the manhole for removal of the material from the line segment. The retrieval winch is designed with a loading chute, in which the bucket comes out of the manhole and deposits the material into a waiting open-top dump truck. On very large sewer pipes where flow, debris levels, and lengths are excessive, conventional equipment and bucket machines simply may not work. For these projects, it may be time to utilize large diameter cleaning technology. The typical way to clean large diameter pipes is to bypass flow from a given segment and then manually clean or use conventional equipment to clean. Bypass pumping is costly and often not feasible. Interceptors or trunk lines were designed for constant flow and conveyance of material to the waste treatment plant. Because of this design, when material is suspended in flow, it must be continuously extracted, because suspended debris does not magically stop at the access point. Large diameter sewer cleaning methods utilize a large volume of water, delivered by a pump and nozzle, to clean large sewers without the use of bypass pumps, in a continuous fashion with large debris tanks. As previously discussed with common jetter operations, the large diameter sewer cleaning method applies a greater amount of pressurized water to the debris. Most sewer cleaning units pump between 65 and 125 gallons per minute. These large diameter type systems pump up to 350 gallons per minute through two 1¼ inch jet hoses to move the larger deposits of material found in the larger diameter sewers. Lengths of up to 2,500 linear feet can be cleaned from one position. Nozzles are tools of the trade for the sewer operator. They can be used for a variety of purposes and can be configured in a myriad of ways. As with most humans, jetter operators are creatures of habit. It is very common for an operator to fall in love with a particular nozzle or type of nozzle and use that tool for all applications. Cleaning and debris removal is a process analogous to building a house. A carpenter wouldn't use the same tool to plane a door as he would to drive roofing nails. Conversely, the jetter operator should not use the same tool to penetrate a blockage as he would to do standard cleaning. There is a correct tool available for every job. Nozzles are specifically designed for the diameter of the hose, pressure water pump, and flow volume of the water pumping system. The rear and at times forward or lateral facing jets are positioned at angles to facilitate the cleaning process. When selecting a nozzle, the operator needs to understand the angles of the nozzle's jets and how they affect the tool's ability to do the work required. What these angles determine are either the nozzle's ability to produce thrust, which is what propels the hose up the pipeline, or wall force, which determines the nozzle's scouring effectiveness. Nozzles may be referred to as a 40-degree nozzle, for example. This should tell the operator that this tool will be an effective cleaner, but generally have limited ability to propel itself. On the other hand, a nozzle featuring 8-degree jets may run up the pipe like a rocket, but provide very little wall force for cleaning purposes. Among all of the types of nozzles out there, a basic debris remover is the hammer in your toolbox. Simple to use and very effective. 30-degree jets or a mixture of jets from 45 to 15 degrees is typical for this type of nozzle. Pipes with blockages or steep grades may need a penetrator nozzle. These nozzles may have an angular tip and forward-facing jet for use in breaking up blockages. They normally have 15-degree or less jet angles. These smaller angles will produce more thrust. This increased thrust will assist you in climbing steep grades or breaking through tough blockages. In sewers with grease deposits, a good spinning nozzle can be the trick. These nozzles have lateral-facing jets which spin as the pressure is increased. Having the jets at a perpendicular angle assists in scouring grease from the pipe walls. Nozzle and tool selection is not difficult if the user understands the basics. Remember, your jetting unit is a great asset, but the system really begins where the hose ends.
We hope that this video has provided you with fundamental information on safe and efficient use of sewer cleaning and jetting equipment. We invite you to use this video, as well as other references, such as NASCO's Jetter Code of Practice, to gain a better understanding of cleaning techniques and equipment selection. NASCO would like to acknowledge all of the organizations that have contributed their resources and expertise to this production. We especially thank Vactor, VacCon, Jack Dehaney Supplies, and Nostech for their generous support. In addition to these platinum and gold sponsors, we offer heartfelt thanks to all of the silver sponsors who, combined, made the funding of this video possible. We also want to acknowledge the many individuals and companies that have contributed content, as well as our own NASCO members for their tireless commitment toward the successful production of this video. Finally, NASCO would like to acknowledge the dedicated and reliable operators and support staffs that keep our sewers flowing. You perform a service that most people cannot begin to understand, and we thank you for your commitment.